Okay. So, as I said, the main part of our plan today is to do that lab 4. So that lab 4 is under the week, actually I think it's under the week 3 tab. Yep. So like the other labs, we've got a video from Svetlana describing to us our process for it. And then the lab under that. But before I kind of let you guys play with that, if you guys have any questions from the homework or questions from some of the stuff we did yesterday or the day before, I would love to look at those and answer those.
How about 6-2, number 10?
6-2, number 10. That's
Yes.
really specific.
Well, yeah, that's where I'm at. Yes, sir.
6-2, number 10. Okay. Assume the probability of being born with a genetic condition is such. A study looks at a random sample of that many volunteers. Where'd my thing go? There he is. Okay, and we're asked find the most likely number, so that's our expected value. Let X represent the number of volunteers who have the genetic condition. Find the standard deviation for the probability distribution. Okay, they're expressing that in a fancy way, but that is just our standard deviation from yesterday. Use the range rule of thumb to find the minimum usual value. That's our 2 standard deviations. Rounded to a whole number because we're talking about people. And the maximum within 2 standard deviations, again, round to a whole number because it's people. Okay. So, if you guys need this again, let me know. But where'd it go? Just like yesterday, we got to grab our information from this problem. So we need our N's and our P's and our Q's. So how many trials are being run here? What's our N?
166.
166. So N is our 166. And then we need a probability of yes, probability of success. So our probability of being born with this genetic condition is even listed in terms of P. That's nice. So that P is our 59 out of 60. You could write that as a decimal if you wanted to.
So when I wrote it as a decimal, I didn't get the right answer.
You'd have to write it as a decimal and keep a lot of accuracy.
Yeah, I had to put it in as a fraction in the equation for it to work properly. Because I guess, yeah, if you don't round right, then it like doubly rounds somewhere along the line. Okay,
it's rounding the rounding of the rounding. So
yeah.
Fractions, as hard as it can be, fractions are always carry more accuracy. They carry, and even if we need that Q, the Q being the other 1 out of 60, the fraction just makes it so much easier to work with. So yeah, depending on the amount of accuracy that the problem requires, it can make enough of a difference. Use the fraction, you'll be in better shape.
Okay.
So then we're asked for what? Mu, sigma, and our 2 standard deviation range. So we're asked for our expected value, or you can call it our mean, because it is our mean. And because it's a population, because we have, it seems weird because like it's a sample of 166 people, but the probability distribution is a population of all the different outcomes for these people. So it is still a parameter for the probability distribution, even though it's a sample of people. So that always seems a little strange. And remember, the formula for that is fairly nice. That's just our NP. And if we've got 166 people, and the probability of them having this condition is 59 out of 60, then, well, 59 out of 60ths of the 166. So that's going to be fairly nice. I always say the hardest thing about expected value of a probability distribution or mean of a probability distribution is being comfortable with the fact that it's just NP. There's a tendency to want to do a lot more with it, and being careful of that is usually the big issue. So what do we get when we take 166 times 59 60ths?
163.23.
163.23. Now let's see, we're asked to find the most likely number of these conditions, round our answer to 1 decimal place, so we can be rounding it to the 163.2. So we can even check at that, 163.2. Is that fair? Okay. Then we're asked to find the, for this, they're saying, okay, let's label this entire probability distribution X, capital X. Okay. We're not really going to do anything with that, but that's nice and formal. Find the standard deviation for the probability distribution. Okay, so we're going to have, on average, 163.2. But like we've talked about, when we're looking at an average, we want to know, okay, average within what range? What's our plus or minus for typical, unusual, and whatnot? So we want that standard deviation. So standard deviation. And again, because it's a population, it's sigma. And again, we've got a comparatively nice formula. That's that NPQ. Or your book likes NP 1 minus P, whichever. So, okay, that's just as long as we have identified those values, we can plug them in. That's our 166 times our 59 60ths times our 1/60th. We have to be a little careful how we type that in, just because there's a lot of parenthesis management there. But that NPQ should be our standard deviation.
Oh. 162. I thought it was 1 minus 59 60ths.
It is. 1 minus 59 60ths is 1/60th.
Oh, yeah. Sorry. My brain got it.
Brains do that. No problem.
It's too many different ways to know this stuff. The answer is 2.7205.
2.7205.
Yeah.
It seems reasonable. I mean, if you told me that number was 107, I'd be like, it seems like a lot. But 2.7, that seems reasonable.
Yeah.
Is that after square rooting it? Because I got a different number after square rooting it.
Ooh.
Yeah, I got 164.94.
Yeah, that's what I got. 1 point.
Yeah, that's what I got too.
I forgot to square root it. Just kidding.
Oh, we can fix that. Just put the square root there. Now you were totally correct.
Yes.
And what did it end up being?
1.65.
1.65. Okay.
Oops.
All right. Hey, look, that happens. And we were asked to round 2 decimal places. So the 1.65, boom. Yes, 1.65.
So what if I do something like that on the test? Because on my paper, I square rooted it. So I know what I was supposed to do.
Yeah.
But
I've
what I
got
mean?
that link at the bottom that says show work. You can always attach anything you want. And also, I've generally gone through them and I can look and go, okay, where did that number come from? If it's wrong, and I can go, oh, okay, that's just the non-square rooted version, or that's, and assign some points to it.
Okay.
So it's not the end of the world if that happens. And if that standard deviation is off, and then we go to that +2 standard deviations, it's going to say that's wrong. But I can look at that and go, okay, that is +2 of the standard deviations you thought you had.
Okay.
And I can go, okay, so given that error, what you did with it was correct. And I can modulate that a bit. So modulate, that's a weird word to use there. But I can mess with that.
Is there any way to add our work papers to the test?
Yeah,
afterwards?
there's a button
So we
at
don't
the
have to
bottom.
take up test time?
What's that?
So is there any way to add it after the test so we don't have to take up the test time?
Yes, you
trying
can.
to submit?
If you want, you can just send it to me
Oh.
as an email or a message.
Okay.
Happy to have that.
Okay.
Do that as stop the test. When you're done with the test, stop the test,
Yeah.
and then send that as soon as is reasonable after the test.
Okay.
But yeah, no, that's great. I'd love to see those.
Okay.
I can even put in a thing so you guys can have a thing to send it to me with directly. Happy
Oh,
to
yeah,
do
that'd
that.
be cool.
So use the range rule of thumb to find the minimum values and minimum usual values. The which means round up. I don't like the which means there, but to find the usual values, because these are individuals, we should take those usual values and round them to whole numbers. But it's saying which means to do that, I think, is a little bit strong of a statement, but that's okay. So our 163.23 plus or minus 2 times the 1.65. So we would need the 163.23 plus 2 times 1.65 and 163.23 minus 2 times 1.65. And that interval is going to be our usual range. And we're, again, asked to round that. So what is 163.23 minus 2 times 1.65?
159.93.
That seems reasonable. And that's going to be a little more than 3, so minus a little more than 3, 159, I buy that. And the other one would be
167. If you round to whole numbers. Gotta round.
well, what is it before you round?
Oh, 166.53.
So we have to be a little careful how we round here, because, you know, that they are talking about rounding, you know, notice one is round up and one is round down. The reason for that is if we're talking about people, our usual range stops at the 159.93. So the question is 159 people unusual? The 159 is less than the 159.93, right? So we've got to round that up to the 160. Now that might seem like, oh, okay, that's normal. But even if this said, say it turned out to be 159.13, we'd still round up to the 160. Because 159 would still be unusual. Fair? We're not rounding to the nearest here. Our interval should be, you know, how many people are how many people are considered our usual range. If 159 is less than our boundary, then 159 is unusual. So it gets cut off. Fair? So it doesn't matter whether this decimal is, you know, 4 or more, 5 or more. We're rounding up, period. Fair? Again, on the other side, the 166.7 or 0.5, sorry, is 167 unusual?
Oh,
If 167 is unusual,
yeah,
what's the boundary for our usual range?
166.
166, regardless of what that decimal is.
Okay.
Fair? This is common when we're talking about individuals. You know, when we talk about, you know, how many people is this actually going to happen to? It can't happen to 166.9 people. And if it didn't go to 167, then it's not 167, it's the 166 people.
So in any equation, because I think I just grasped this part, in any equation when we're trying to find those outliers and we get to this part, whatever our numbers or our problem is, we always relate it back to our original number of trials, or like our number. Like in this instance, it's 166 people.
Mm-hmm.
So that's what I'm relating it to figure out if this number is an outlier or not, correct?
If it's unusual or not, yes.
Yeah, that's what I mean, if
Yep.
it's unusual or not, because I was really like wishy on that.
Yes.
Oh, got it. I totally get it. Okay.
And, you know, because these are included values now,
Right.
they switch the interval to square brackets, as they should have.
Mm.
So yeah, we get really in the habit of when we round, we, you know, look at that number, the, you know, number right after. If it's you know, 5 or more, we round up. If it's less than 5, we round down. That is not an unreasonable convention. It's called rounding to the nearest, but we do round up and round down for other reasons. So we want to be careful. Like, are we rounding to the nearest because, you know, we want the nearest value, or should we be rounding up or down for a particular reason? Jesse, you had asked about that question. That work?
Yes, it worked. I saw my mistake. Of course, if I got the second one wrong, I would get the third one wrong as well. And
Yes.
my problem was I didn't that minus part I missed. The Q minus one or whatever.
Yeah, the P minus one. And
Minus
if
one.
you were
that's-
using that formula, it still works, but that's where things can go wrong.
Yeah,
So
that's
that-
why I put the wrong number in there. And so I thought I had the formula pretty right, but I put in the wrong number.
You could put that in that way, but the parenthesis management's a little bit more, you have to be a little bit more careful with. I just like the Q. I think it helps separate it and makes, I think it makes a lot of the formulas easier. It makes a lot of our lives easier.
Thank you. That was the difference. It
Cool.
was a brain error.
And those happen. I'm not, as long as the idea is making sense, if the mistakes that you're making or you're finding you're making are like how it's being put into the calculator, little, oh, I put, those little kind of, brain error problems as opposed to, I don't know what I'm doing. Those kind of mistakes, they can be frustrating, particularly because my open math will say no and not give you a lot of extra information. But if those are the types of errors that are happening, then that means, you're getting what's going on, which is good. You just need some practice so it's more comfortable. So those, kinds of errors happen less, but that means we're on a good path towards being happy.
Wouldn't it, hey Matt, wouldn't it be cool if we could have my open math after you missed like your three times, then instead of just showing you the answer, they showed you the work so you could compare that to your work? I mean, I don't know if that's ever going to happen, but.
Some of them have something similar. But yes, if it could do that better, that would be more helpful.
Yeah.
But some of them, might get to that. What was it, question 7 that we were working on, or 10? 10.
Some of them have little videos, right?
Right.
But
And some of them, I hate when it does that. You can't submit the same answer twice. Notation. I want to get to the point that it's saying no.
I have another question.
Okay, 1 second. Why isn't it stopping me? Okay. Anyway, there are some of them that do have a show work thing to them, but not very many. But yes, that would be super helpful, but that's mostly a software issue. Yes, what was your...
Brackets are, square brackets are just to hold two numbers in place, correct? And then the other brackets mean something else? I just forget why they had us use those brackets in.
So if we say have our 159, our 160, 161.
Okay.
I'm just gonna make a list here. 163, 164, 165.
Because it makes a difference on your answer, doesn't it?
Oh yes.
Yeah.
And it does mean something different.
Yeah.
So if we are going from 160 to 166, there are two ways we might want to signify that interval. If you use the parentheses say we start at 160 and go forward, but 160 is not in our interval.
Oh.
So graphically, we often use an open circle to 166 with an open circle. That would be from 160 to 166, but not including those endpoints.
Oh.
Now, because these are whole numbers, there's nothing in between 160 and 161 because we're talking about people, right?
Mhm.
But if this was a continuous variable where 160.3, 160.4, 160.8 were all possible, then we might want this for a more than 160 but less than 166. Fair? But because these are whole numbers where we rounded, down and up, and we want to say, okay, start at 160, but include it. So I want to include the 160, and I want to go to the 166 and include that number as well. So the difference is those endpoints. The square brackets say include this value and include that value, where the parentheses say, okay, start here but don't include it, end there but don't include it. And you can even have them mixed. Let's say you went from, say,
Right.
5 to 10. That would be greater than or equal to 5, but less than strictly 10. Does that work for you?
Yeah, thank you.
Sure. Messages here. Okay. Yeah, no problem. Okay. Got anything else you want to ask or look at before I set you on the lab?
Did we wait to do the quiz on Monday? Is there anything, if we've done the lab and all the assignments, should we be good for the quiz?
Yes.
Okay, so we can go ahead and get that done.
There's not one little thing that maybe we should look at. Maybe we would want to pay attention to.
I don't know what's on the quiz. What happens when the shape of binomial distribution, number of trials increase? Okay, so that's mostly read your section. Manufacturing 6% deficit. We did a bunch of those yesterday, so we'd have that idea. 80% people own dogs. How many dog owners? So that's an expected value question. So yeah, no, we've done all that. And now it's gone.
Jesse's like, oh, I'm so close.
That's ornery.
I know.
No, you know what? Thank you, because I don't know any other teachers who would even they tell you crazy stuff. That's appreciative. I had a math teacher who said, here's do the practice quiz. It was like 5 pages of practice quiz.
Mm-hmm.
Yeah, this is what's going to be on the test. We got the test. It wasn't anything even related to that. It was so hardcorely different. I was like, oh my God. I spent all my time studying some crazy stuff, and that wasn't what it was even on the test.
Well, if you put it on the practice test, then everybody practices it, and they can do it.
Oh my God.
So
Yeah.
why not test them on other stuff?
No, that's not okay.
That makes perfect sense, though.
That is cheesy.
I got you to practice that. I know you're good with that. Okay, so
Coolio.
you guys can just jump into that lab,
Nope.
and I think we're in week 4, but I think the lab's under week 3 because I moved the schedule around.
Right.
So yeah, jump into that lab. It is using that binomial dis or binom dis tool that I was using a little bit yesterday. So it should be tools that you're fairly familiar with. It does ask you to make some fairly big charts out of them. But yeah, jump in, play with it. I'll be around for at least an hour or so you guys can ask stuff on it. Or if you want to work on it, it's not due until Monday, so you can work on it whenever you want to work on it. But it is nice to work on it when you guys are here and can talk to each other. I think there's few enough that if you guys just wanted to kind of chat with each other back and forth about it. I am going to encourage you guys to chat with each other about it, kind of before you try to chat with me about it, because that having to have that dialogue with each other about it can be super helpful. Trying to figure out how do I word this and how do I word an answer that might be helpful. That back and forth can be super, super, super helpful. So I'm going to encourage you guys to do that.
Camille, did you finish it?
Yeah, and I
Yeah.
turned it in.
Yeah, me too.
I mean, as far as wording it, I just kind of repeated what it said.
Yeah,
in a
me
way. Like the expected value or the expected days that you would get clear, and then I put the decimal number, and then I thought, well, that's kind of weird in a sentence, so I said or, and then I wrote a sentence and I put the percentage.
That's exactly what I did.
Yeah, because it sounded better as a percentage, but it
percent.
looked better as a
Yeah.
percentage. So
I think that's great.
yeah.
Oh, you
But
guys
I
talking
found
about
on
that hand in
Excel,
homework?
I was like, I did all the work, and I'm like, yesterday I went to go do the questions, and I think my brain was just had enough, and so I sat down today, and I was like, the work is done. I don't have to do anything. Like,
Yeah.
just look at the Excel paperwork that I did, and then I just had to add up,
Yep.
and it gives you the sum at the bottom of the page. I was like, okay, this is nice. I like didn't have to do anything. Well, I mean, I did, but I made sure to understand what it was
I think
that I was doing.
I was kind of surprised though, Matt, if I did it right. It said that you don't have to do the CDF column, but I did it just because I wanted to see it. And then it seemed to me that I used almost all of the CDFs for the.
It's easier.
So it's much easier if you do the column with CDFs.
I think so.
I used the CDF the first time, and then I just used the PDF and added them together,
Oh,
which you just have to click and drag the boxes, and then it gives you the sum of them anyways.
yeah. But if you do the CDF column, then they're all there.
Yeah.
Sometimes you got to like subtract a couple of them.
Yeah.
And as opposed to subtracting a couple of them, you could use the PDF and highlight. And
Yeah.
that's fine too.
Okay, sounds like I did that. Okay.
Well, that's good that we did it right then.
Yep.
Yeah,
Okay, I'm gonna go take my quiz.
me too.
Bye, Matt. Thanks.